right, 2004, number 3, another one with a table. It says that a test plane flies in a straight line with a positive velocity v of t in miles per minute at time t minutes, where v is a differentiable function of t, so we take the derivative, figure out its acceleration. Selected values of v of t are shown from 0 to 40, so we're going in increments of 5 minutes. Part A asks us to use a midpoint Riemann sum. So like I told you before, with a table, you're almost guaranteed to end up with a Riemann sum or trapezoidal approximation. So a midpoint Riemann sum with 4 subintervals of equal length, and using the values from the table to approximate the area under the curve from 0 to 40 of v of t dt, or the definite integral from 0 to 40. Using correct units, explain the meaning of this. So we had to do that in that last problem too. Explain the meaning. What does it mean? What is the definite integral of velocity? This is something we've talked about before. Change in position, right? Displacement, right? But in this case, usually we'd have to put absolute values to get the total distance, but since this tells us velocity is positive the whole time, this is also like the total distance. So even if we didn't figure out the rest of this, we can answer this part. So for part A, the definite integral, we're going to have to fill in the blank on what it equals. All right, that's going to be approximately equal to something. We'll figure that out in a second. And we want the correct units. So what units would this be in? We're talking about that distance traveled from t equals 0 to t equals 40. It's going to be in miles, right, the distance. So this is the distance the plane travels from t equals 0 to t equals 40 minutes. Right? That's all it is the distance the plane travels. Now we need to approximate that. And we're using Riemann sums, midpoint Riemann sums. So again, me personally, it helps me to kind of visualize with a graph. We might not have to plow out everything, but we're breaking this up into 4 parts. So we're breaking this up into 4 equal parts. How big is each part? 10, right? So we're going to go like from 0 to 10, 10 to 20, 10 to 30, I'm sorry, 20 to 30, and 30 to 40. Now we could go ahead and plot all of these points on this graph, but which ones are most important? Those ones, the midpoints, right? Since we're doing a midpoint Riemann sum, I don't really care what 0 is or 10 is. I care where is it when t is 5. So when t is 5, this is at 9.2. Right, so we're going to have other points like down here at 7 and then 9.5, but the height of our rectangle that we're using to approximate the area is at the midpoint. So we're going to draw a rectangle right here. Well, this rectangle has a base of 10 and the height is going to be that midpoint, 9.2. So we're going to have 9.2 times 10 for our first rectangle. Our second rectangle is going to have a height when t is 15, so that's going to be at 7. Right, that's the height of our rectangle. So we're going to have 7 times 10. When t is 25, velocity is 2.4. That's going to be the height of that rectangle. 2.4 times 10. And we have one last rectangle. When t is 35, it's at 4.3. Right, so we have 4.3 times 10. So if we add all those up, we get approximately 229 miles. Right, so that's the total distance the plane travels in that amount of time.